Hey, good morning, everyone. So my name is Alon Head. I am senior editor at The Air Current, and I specialize in coverage of electric vertical takeoff and landing, or eVTOL aircraft. So this morning, I am honored to be sharing the stage with two of the absolute leaders in this space, Kyle Clark from Beta Technologies and Bonnie Simi from Joby Aviation. So both of these companies are flying real full-scale aircraft, and they're both making good progress on the path to certification. And they're also both targeting slightly different markets, which I think is interesting because it illustrates the range of use cases that these aircraft can serve. So to kick things off, I'm going to ask Kyle and Bonnie to introduce themselves and their aircraft and tell us a bit about the missions that they're looking to serve with these new vehicles. So Kyle, maybe you can kick things off.
Sure. Hey, I'm Kyle Clark from Beta Technologies, and we, as Alon mentioned, are designing, developing, and certifying and hopefully deploying electric vertical takeoff and landing aircraft, charging systems, pilot training systems, all the things necessary to fly them. But as Alon said also, we are focused on initial deployment into military applications in cargo and logistics, then civil applications in cargo and logistics before moving into, hopefully, passenger service. And just gross characterization of that choice, we decided to go after cargo and logistics as we saw less impediments to market entry, mostly around where and how we can deploy these things, the sensitivity around going into city centers and residential and places where there are people is much higher than going into places like industrial parks, hospitals, military bases, and places that big trucks roll in and out of all day, every day. So that's our market entry strategy. However, a lot of the same technological challenges, certification challenges, are similar between these types of market entries. And in fact, from the FAA's perspective, there's really not a lot of difference in certification between a cargo aircraft and an air taxi. But I'll let Bonnie talk about her entry point.
Sure. So I'm Bonnie Simi. I lead air operations at Joby. And Joby's a very vertically integrated company, so we're designing, building, and then plan to operate our aircraft. So I think of it as the airline piece, so I oversee that. My background is in airlines, spent over 30 years at United and JetBlue as a pilot. So when we think about our aircraft, the company's been around for over a dozen years, and we've been flying our full-scale prototype for the last 5 years, over thousands of test flights. We're currently operating at a public airport in California, so this is getting used to operating in a public environment. So like Kyle mentioned, we have a slightly different model. So we are looking at entry into the commercial space. We've already got our 135 certificate, and we'll be adding the Joby aircraft onto that certificate. So we're operating now with conventional aircraft, and we'll be adding ours. Our aircraft now is, like I said, over 1,000 test flights. We're partnering, like Beta, with the Department of Defense, which is an excellent way for us to de-risk our operations. We plan to be operating on military bases here in the U.S. Very soon, which allows us to test out the operation, the turn time, the battery charging, et cetera. The way one would use our aircraft, so it is piloted, 4 seats. We've demonstrated a range of 150 miles already and 200 miles an hour. It's 4 seats, 4 passengers, and we see it as aerial ride sharing and very multimodal. So you could pull up, we have a partnership with Uber, for example. You'll pull up an Uber app, you can connect a car to a vertiport, heliport, airport, through general aviation, through the app, or through a Joby app, or other multimodal, connecting perhaps with airlines. And then we bring you, the vehicle will bring you to the Joby aircraft. We fly you to the next step and on into downtown perhaps. Overall, we're anticipating launching operations in 2024, although I will say that none of us completely control our destiny as we're going through the certification process, but I think, Elon, you've picked two companies that are well along our way.
Yeah, absolutely. So speaking of certification, so both Beta and Joby are startups, which is quite impressive in the aviation industry because there are enormous barriers to entry. And a lot of those have to do with certification and everything that you have to do to demonstrate to the FAA that these aircraft are safe to fly. So Kyle, I'd like to start with you. Can you tell us a bit about how Beta is approaching the process of certifying your aircraft And what are some of the regulatory gaps that you're still working to close with the FAA? Because this is obviously a brand new type of aircraft that hasn't been certified before.
I think starting with a premise that the FAA and any one of these startup companies, especially us, want the exact same thing. We want a safe, reliable, and repeatably produced aircraft. And if we're all pointed in the same direction, it makes the conversation easier. And then when we look at the aircraft itself, we look at things that are like fundamentally true within the context of Mother Nature, and then we look at things that fit within the existing regulatory environment. And when those two things are solved for, there's a small gap of things that have not been really proven and things that haven't been addressed in the existing regulations. And recently, there was a seemingly large change, which I actually think is a pretty small change, in certification basis or the definition and designation of certification from a 2117A to a 2117B aircraft, which is a standard to a special. And when that happened, it actually, in my opinion, was a big positive for the industry, because although we had this like seeming, I would say, clear path to certification, it left the unknowns bigger unknowns and how to address these special conditions of fly-by-wire, electric propulsion, and verticality. When we went to a 2117B, it said, look, we're okay with these types of differences, and we're going to pull from existing standards, Part 23, Part 27 for airplanes and helicopters, and then we're going to add things like ASTM standards and fill those gaps in a defined way. And so for both Joby and us and others in the industry, we were able to take our certification basis, do a little Control-F, Control-V type thing, resubmit the thing with better definition. It went into a space where the legal assessment of this is unblocked. And right now, Alon, it's actually refreshing and clear as to how we go from where we are today to a fully certified aircraft with a lot of hard work to do, but less ambiguity in the process.
Yeah. And I could build on that too, looking at it from an operations perspective. So initially, at least for us, we were certifying as an airplane. And now this allows, with the new special conditions, it allows us to pull the best from the helicopter regs, the best from the aircraft regs, and then the operating side of it. So there will be an SFAR, special FAR, that will address all of these, and it also will allow us to operate much easier into different airports. It gives air traffic control more flexibility. So, and indeed, the FAA has moved very quickly to, I mean, we, again, did do the Control-F, Control-V and resubmitted, and it got accepted. So there really isn't any delay, and actually, it's a better outcome for us.
Okay, excellent. So building on the operations side of things, like Joby obviously plans to operate its aircraft as well. So what are some of the certification considerations on that side, and how are you laying the groundwork for operating your own aircraft?
Yeah, so this is one of the benefits of being vertically integrated. So we can think now on the maintenance side. So we're building out both the OEM, building out the manufacturing and the manuals, which then, as an operator, we'll be able to accept immediately. So that allows on the manufacturing side, on the maintenance side. The other piece is allowing us to think through the certification of the pilots and going through training for the pilots. We also know there's a pilot shortage out there, so we're building out a pilot academy. We're building out the training right now for our Joby aircraft in partnership with the DoD. We have a simulator here in DC, and we bring in some various members of the Air Force, and we have instructors testing out our curriculum. And we've also partnered with CAE to build out a simulator, because the aircraft is single piloted, single controls. And so simulation is required, so we'll have a very robust level C sim to allow us to put the aircraft on our certification. But it takes, just as it takes a long time to build the aircraft, it takes a long time to build a simulator. So we've already begun that process. It allows us to think through what the regulations are. It allows us, and we've partnered with Beta and also Gamma and the rest of the industry on what should that special FAR be, and how do we think about operating optimally and safely within the environment. And so literally at the table at conversations, whether it be here in DC or in policy or even at Joby, having the operational mindset at the table as conversations about how do we think about headsets, how do we think about profiles into airports. We run these in our own simulators to think about operating in the various major metropolitan areas, and it brings that operational mindset into the design. So my maintenance team is working directly with the engineers to design, not just for manufacturability, but design for maintainability. How do you do quick turns? How do you do 100-hour inspections? How do you do all that on the aircraft?
Excellent. So one of the questions that I hear a lot is, what can these vehicles do that's different from what helicopters are already doing today? And I say this as a helicopter pilot would love, but helicopters are really noisy. So noise is, I think, one differentiator. But I know that sustainability is also really important to like both Beta and Joby. So Kyle, maybe you can talk about how you're viewing sustainability and what you have to do to make sure these aircraft are sustainable, like beyond just making them electric.
Yeah, absolutely. There are two big facets of sustainability, in my opinion. It's the actual aircraft itself, its contained batteries, and the total product's impact. And then there's the operational impact of the product. The operational impact of the product has a huge advantage right out of the gates. Anytime you take diesel or leaded fuel or even unleaded fuel out of the aircraft and you're replacing it with something that is converted from an energy form to a propulsive form in the 80 to 90% side instead of 25%, you start with a huge advantage. And then the next question is, where are you getting that energy from? And in Vermont, I'm proud to say that we are the highest ratio of renewables to carbon emitting energy, and we're over 99% renewables in Vermont, which is pretty cool. I hope the rest of the country goes there, because then the energy source for the airplane all of a sudden becomes a very, very minimal impact. So that's pretty easy to understand. The place where I think there's the biggest variable is actually in the batteries. So we actually, this is kind of neat, we're building our facility. It's about 500,000 square feet to build our aircraft in it in 2 phases. It'll be the largest net zero building east of the Mississippi. Net zero. The building will operate with heat pumps and solar, and it'll build aircraft in a place where we're not making impact there. However, we're pumping the thing full of lithium-ion batteries. And the interesting thing about lithium-ion batteries, it's not like fuel. They're very sensitive in different dimensions. And I've heard people say we're going to get 50 cycles, 100 cycles, 1,000 cycles, 5,000 cycles. And in all my prior experience in batteries, the same argument was made about grid-tied batteries. And it turns out, if you cycle a battery between, say, 40% state of charge and 80% state of charge, you'll get thousands and thousands of cycles out of it. When you charge it all the way up, you create irreversible reactions. And for every 10% lower that you discharge it, you half the life of the battery. So fast forward to the design of the airplane. If you design an airplane that's operating in a very comfortable range of the batteries, and everybody's thinking, am I overcharging my cell phone? Yes, you are. You're ruining the battery of your cell phone by all the way down, all the way up. You operate in that middle region, it'll last a very, very, lithium polymer or whatever you're using, a very long time. So if you design an airplane that has an operational mission of 120 miles, it has an FAA reserve plus some margin, and you don't have to charge it all the way up, you can get thousands of cycles out of that battery, and all of a sudden your net environmental impact of the battery is negated, or 1/10 of what it would have been if you beat the thing up. And the last part is we're building a charging network where we take those modules out and we put them on the grid so that the overall grid can reduce its dependency on diesel spinning reserves, and we reduce the transmission and distribution burden on the grid, which is inefficiency, by putting energy storage at the source of charging. So you have this 330 kilowatt hour battery that you pulse charge at about 1,000 amps, and the grid says, I'm okay with that because you've got this arbitrage of batteries making up the difference.
And Bonnie.
Sure, I can build on that. And also the benefit of VTOLs perhaps compared to helicopters. So we're building on using the range and how much you charge and discharge the battery. So as I mentioned, our aircraft has a range of 150 miles. That is not going to be our normal mission, precisely as Kyle mentioned. We don't want to drain the battery down and up again. Ideally, the range is probably going to be 25 to 50 miles is going to be a normal mission, which will allow us to do those quick charges 5 to 10 minutes in between turns. So think of aircraft turn time. Aircraft don't make money on the ground, they make money in the air. And so we want to be able to utilize that battery technology to keep us within that range. So we've tested 10,000 cycles on our batteries. The other piece that's important for us, as Kyle mentioned, is where does the electric charge come from? And this, right now, as we're thinking about and partnering with different airports and looking at what is the charging infrastructure? We've built out our initial manufacturing facility. We're building on our first pre-production aircraft as we speak, and we're completely renewable. Now, California isn't quite like Vermont, so we're not 100%, but we are very choicefully choosing renewable. So our manufacturing processes are 100% renewable energy. And then as we think about operating in the airports, I just came back from the UK. We've mentioned that we plan to cross-certify with the CAA in the UK. So thinking about what are the airports, there's a lot of infrastructure grid upgrades that are happening both here in the US with the latest infrastructure bill, as well as across the globe. And so talking about airports, as you're doing new runways, as you're building out new terminals, think about laying the electric connections into the grid and thinking about upgrading the grid. How might you come up with renewable energy? So those are areas. The other piece that we're very passionate about, because we are going to be operating in major metropolitan areas, is the sound. Because, you know, safety is number one for us. Sound has been the number two. Our aircraft, we've tested it, is when it flies overhead at a typical flight pattern that you would be coming into a city, say at 1,500 feet, it just blends in to the noise of the city. You don't hear the aircraft at all. You can actually go on our website and sort of see and listen to the sound. It's about 45 decibels. At takeoff, max power is 65 decibels. So helicopters are over 100, and it's a logarithmic scale. So more than 100 times quieter than a helicopter taking off. So that kind of gives a little sense. So we're very, very, you know, when you think of these cities, a lot of the bans that are going into effect or the limitations on operations for helicopters, it is not because of safety, but it is actually because of noise. And so that is really a key factor for us.
Excellent. So let's dig a little bit deeper into infrastructure. Another question I hear a lot is, well, you know, where and how are you going to charge these things? So Kyle, you have some experience with this. Tell us, where and how are we going to charge?
First of all, I think it's neat. I love everybody here from traditional aerospace, but our goal is to get rid of the three most annoying things in aerospace: the runways, the fuels, and the fuel and the noise. So that's like, I would say, a very high level goal of all of us. As far as the charging goes, yeah, we believe that the charging of the aircraft, first of all, it's very important to the safety and sustainability of the aircraft, not in an environmental sense, but the actual aircraft itself. Batteries have little sense of humor to doing things wrong, pulse charging and microcycling, all that type of stuff. So we actually design and build our own charging systems, and we put a network all the way across the country, well, halfway across the country and down the East Coast, that we flew recently. We flew from Vermont down to Bentonville, Arkansas, and back, charging at our own chargers, and we built a mobile charging system to fill in the voids. And I think the infrastructure that we need to have is, as Bonnie said, think forward on your airport planning to put in the power drops. Think about the types of chargers, ensure they're multimodal and interoperable. And we populate all the airports for transient aircraft. And then we have strategic endpoints that go to hospitals, bases, and city centers and industrial parks. And yeah, it's a big, an important thing for us all to deploy these sustainable aircraft.
Okay. So Bonnie, another question I get a lot is, you know, where are these things going to land, especially in cities? So how are you working on addressing the infrastructure for air taxi operations?
Our aircraft is designed completely to fit into the existing infrastructure. So it's piloted, so we'll work with air traffic control. It can land at any heliport, it can land at any airport, so it can take off vertically, it can land or take off conventionally as well. So we fit existing infrastructure, which I think is very important as we think about public adoptance. And it does take, you know, there's not only are there places where we can, so think about the tops of parking lots. There's a lot of parking lots now. We have infrastructure partners coming to us now. How can we repurpose? We are first deploying into some of the regular airports and heliports as we build a network of the tops of parking garages. So airports themselves, even the top parts of parking garages, a great way to reuse them. Again, it's about building out, though, the electric grid and electric infrastructure into those. So it's a long lead time to be able to deploy a brand new, we'll call it vertiport. The FAA's just put out new standards for that. So we're working that in parallel to operating at existing airports. And as I say, we're currently operating. We fly every day at a public airport in California. People can go and watch our aircraft fly. And so we're using that infrastructure as we speak.
Excellent. And just to wrap things up quickly, how do you, foresee eVTOLs becoming part of our daily lives in the future? So, Kyle.
I think the first thing we need to recognize is that the technology works. We need to create a framework in the United States through, I think the military has a big role to play here in supporting the adoption of these. They have mission sets that we can solve today. The Army, the Air Force and Marines, the Navy, they all have mission sets. We need to support that. We need to work together as an industry along with the FAA to create this regulatory framework or fill in those minor little gaps. And if we get in our own way, then we're going to get surpassed by the rest of the world. He's going to be deployed elsewhere before us. And I think it's a matter of national security. It's phenomenal technology, has tons of promise. The market knows that. We all know that as aerospace professionals. And I think the public is starting to realize that this is the things that we're proposing to do, all joking aside about noise, fuel, and airports. This is a transformative thing. It moves down the curve to accessibility, and it brings aerospace into a whole nother world of verticality and sustainability. And if we work together on doing this, and we support, Congress supports the military in adopting this, we fill that big chasm that we're all running towards before we get to launch commercially, then we will have a successful launch commercially.
Yeah. And I'll just build very quickly. You know, I see us building into the regular fabric of how we all get around. Initially, we can use it as places where helicopters are currently being used, maybe the downtown to the airport. We're safer. No single points of failure on our aircraft. We're quieter. And so we fit into the environment very well. And then gradually, as more and more adoption, we see as fitting into the fabric of everyday's life, it brings the cost down so that it would be no different than taking an Uber from one end of town to the other, but a lot faster.
Excellent. Well, thank you both very much. And, thanks to the audience, and looking forward to seeing these come to fruition.
Thank you.
Thanks.
Thank you.